Hello, this question is from GATE 2023 and this is from the domain of nuclear physics. The question states the deuteron is a bound state of a neutron and a proton. Then, which of the following statements is or are correct? So, it's the multiple select question MSQ. Okay. So, the four options are option A, the deuteron has a finite value of electric quadrupole moment due to non-spherical electronic charge distribution. Option B, the magnetic moment of the deuteron is equal to the sum of the magnetic moments of the neutron and the proton. C, the deuteron state is an admixture of 3s1 and 3d1 states. And option D is the deuteron state is an admixture of 3s1 and 3p1 states. So let us solve the problem. The first is about the quadrupole moment of a deuteron. So the quadrupole moment of a nucleus is given by Q equals 2 by 5 Z times B square minus A square. So for B equals to A, we will have Q equals to 0. Okay. And for B not equal to A, Q would have a finite value, non-zero finite value. So the first case is for the spherical nucleus and the second one is for the non-spherical case. And deuteron is an example of that. Okay. So we can say that a deuteron has a finite value of electric quadrupole moment due to non-spherical electronic charge distribution. So option A will be correct. Now let us check for option B. It states the magnetic moment of the deuteron is equal to the sum of the magnetic moments of the neutron and proton. Now we know the magnetic moment of proton is 2.79 mu n, and that for neutron is minus 1.91 mu n. Also, the magnetic moment of deuteron experimentally is 0.88 mu n. So this is a experimental result, and this is I would say that it is known from the theory of this deuteron. So if we just take mu p plus mu n, so 2.79 minus 1.91, which is 0.88 mu n, and this is not equal to mu deuteron. Okay, so option B is incorrect. Now, before proceeding to the next step, we all know that okay. So first thing is deuteron is a even parity state. Okay, so deuteron state has even parity. Now for a state L equals to 0, so this implies the parity equals to minus 1 power L, which is also plus 1. For P state L equals to 1, so the parity equals minus 1 power L, which is minus 1. And for D state L equals to 2, which gives parity as plus 1. So it is not a mixture of 3s1 and 3p1 state, and it may be a mixture of 3s1 and 3d1 state. Now we know that from the theory that ground state of deuteron is a mixture of 3s1 and 3d1 states, okay, where 3s1 is present as 90 with weightage of 96% and 3d1 is present with weightage of 4%. And also it is interesting to note that because of the presence of these two states, the deuteron nucleus is not exactly a spherical nucleus, but it has some changes in the shape. And because of these changes, mu d is not equal to mu p plus mu n. So option C will also be correct. So option A and C are correct here. Thank you.